2.6, this is what you're really going to be doing for your homework, okay? Spaghetti sauce. I had spaghetti for lunch. I had spaghetti for dinner last night that I had to get today for lunch. Anyways, this is what you're going to be doing. Your homework will look like this. Now, take the derivative. Remember, the derivative of 2y, of y squared, sorry, is not 2y because it's the dependent variable. You have to do a chain rule. You want to think of it like y is like the g function, and we have to do a g prime after it because the actual value is, the variable is x. So then, you want to solve the equation for y. Notice that the derivative is going to have x's and y's in it. Okay? And the derivative is going to have x's and y's in it. So there it is. This is what you're going to be doing. This is the quintessential one. Like, if you were to have one question on a test and you were to say, this has to be it, this would be it, like this, right? So here we go. 2x. There's a product rule going on here. So it's first times the derivative of the second plus the second times the derivative of the first. So this part here plus 2y y prime equals 0. Now, just a couple comments here. Don't forget to make that 5 a 0. Just kind of like over here, the derivative of 7 is 0. That is honestly the most common mistake on a test. Okay? The most common mistake on a test, at first you might be going, oh man, this seems hard. No, I'm telling you, by the time we take a test on this, the most common mistake will be forgetting to take that derivative. Now, what do I have here? I have 2x plus 3x times y prime plus 3y plus 2y y prime equals 0. Like I said, this is like a very typical question you have, okay? So notice I got two terms with y primes and two terms that don't have y primes, right? So you got to separate the variables, right? So I'm going to leave the y primes on one side. Now you might go, Mr. Peters, does it matter which way I move them? No, not at all. Personal preference here. And then I'm going to move the green ones over to the other side. Now, keep in mind, you could have done it the other way, and it will not affect the outcome. Okay. But you have to separate the things that have y primes from the things that don't. And this is a big deal because this is how the homework will go. But you'll see it; it'll repeat over and over again. Is you're going to factor the y prime out. The reason you put all the y primes on one side is so I can factor out the y prime. And you can't do that if you got all the crap over this. That's why we had to move the ones without the y prime over. And then notice you're done. You just divide. That's it. That's the derivative. Again, notice the derivative has x's and y's, which is kind of weird. Okay. Notice what we're doing. We're taking the derivative of things that are not functions. Okay. They wouldn't pass the vertical line test. Okay. What about something like this? What about trig? Again, we got two product. Oh, that's going to be a bloody mess, isn't it? I'm going to have two product rules, aren't I? It's going to take up this whole board. I might have to actually slide over just a little more just to make sure I have room for it. Right? So first times the derivative of the second. There's the implicit differentiation idea. Chain rule on the y. Plus the second times the derivative of the first equals the first times the derivative of the second plus the second times the derivative. Here's the other chain rule, or implicit differentiation. So let's clean this up a little bit. X squared cosine y times y prime plus 2x sine y negative y cubed sine x plus 3y squared cosine x y prime. Order is not that important, but personal preference here. Now notice the same thing is going to happen here. I've got two terms with y primes in them and two terms without y primes in them. Now, just to be different, I'm going to move the y primes over to the right side to kind of show you that it doesn't matter, and I'm going to move the things without y primes to the left side. So, if I do that, I'm going to have 2x sine y. I'm going to move this over, plus y cubed sine x. I have this here, 3y squared cosine x y prime, and then I'm going to move this over to the other side, x squared cosine y y prime. So I move this over to this side, so it becomes negative, and this is negative. I move it over to this side, it becomes positive, and these two, of course, stayed where they were. And then the reason we do that, of course, is so we can factor out the y prime. Hold on. X squared cosine y. And then the reason we do that is so we can divide it over. Now I'm hoping this fits. Should probably stop and turn around and see what my thinking on it is. I want to finish writing here, and then I'll fix it if it's not visible to you right now. So don't panic. So notice that if you solve for y prime, your y prime ends up on the other side, but that's not a big deal, is it? Oh, and it all fit. Groovy. Okay, third one. Square roots are annoying. I'm not gonna lie to you, they're just pain. So I got a product inside that square root. So the first thing you probably want to do here is rewrite it as x, y, to the 1/2 equals y. So I just rewrote the question, right? So then when I go take the derivative, I cover it up. I get 1/2 x, y, to the negative 1/2. And then this is where it gets kind of funky. We have to take the derivative of what's inside. And then you bring the power down. So you got a chain rule going on in an implicit differentiation situation, right? So it's kind of making things as complicated as we possibly can, which is not an unfair statement about this question. So I made the other side kind of easy just because I want to focus on the left side. Now, again, so you brought the half down, reduce the power by 1 to the derivative of what's inside. The x times y, that's a big one. You almost, like you do this one so often, you just memorize it. First derivative of the second plus second derivative of the first. Now, you gotta listen to me here. You gotta believe me on this, okay? Rewrite it back the way it was. If you don't, you're gonna treat it like the last question, then there'll be a problem, okay? Oh no, not really the last one. But here's the deal, here's the deal. You don't wanna distribute the fraction in. It would not be wrong, and it would eventually lead to the right answer, but it'd be much more painful. Distribute this over to the side. If you bring this over to the other side, you get 10 square root xy y prime, and then bring the y prime over. Now it's like all the other questions. What am I getting at here? Don't futz around with the fraction. Guys, don't mess with the fraction. So then I'm going to move, okay, let me stop here. You guys, this step here is important. That you multiply this over to the other side. Okay? Now it's like all the other questions we did. I'm going to move the y primes on the same side. And the reason I'm going to do that, of course, is so I can factor the y prime out. so that I can divide. Now, one thing you probably, well, maybe you thought about, maybe you didn't. Fractions. Notice we haven't had any fractions. Like it's all like even on the last video, they were all products. There's no fractions in implicit differentiation. Guys, let me say that again. There's no fractions in implicit differentiation. There's no quotient rules. It's just product rules. That's why in the first video I only did, but remember I did like 8 or 10 product rules for practice. You're like, Mr. What do you do if there's a fraction? You do the same thing we did in the last question. Get rid of the fraction. Cross multiply. One of the things that is nice, there's not a lot nice about this topic in a sense. One thing that is nice is there's no fractions. Okay. Squared plus 3xy squared. 5x squared y plus 5y squared. That's a lot of work to get started with, but that's what you got to do. You got to get rid of the fraction. Don't try to do a quotient rule with this stuff. It gets horrible. I kind of alluded to it in this question here. You guys, don't distribute that fraction in. This one's not as bad as the other one. No. What you want to do is get rid of the fraction because we have the equal sign. Remember yesterday I just had expressions. I didn't have any equations, just had expressions. So make sure that you get rid of it. Now it's like all the other questions we did, right? 6x first times the derivative of the second plus the second times the derivative of the first. First times the derivative of the second plus the second times the derivative of the first plus 10y prime. It's kind of a pain because you got two pretty massive product rules going on there. So you got these big product rule here, you got a big product rule here, and then of course you got the 5y squared and the 3x squared too. Now, let's clean this up. So we got 6x plus 6xy y prime plus 3y squared equals 5x squared y prime plus 10xy plus 10y y prime. So you got some things with y primes in them again. And you want to put those all on the same side. Since there's already two of them over here, I'm going to move this one over here. And then that means I'm going to move this one. There's all the things without y primes. I'm going to move that one over that way. Just probably because it's less movement, I guess. So what do I get? The green ones are 6x plus 3y squared minus 10xy. And then the blue ones are plus 10y y prime minus 6xy y prime. And again, it's like now it's highly repetitive. Then you factor out the y prime. So that you can divide it. 6x plus 3y squared minus 10xy all over 5x squared plus 10y minus 6xy. Now for some reason, 4 of the 5 questions I ended up with the y prime on the right. It doesn't matter. Again, back here, you could have moved the 2 blue ones over here and the 2 green ones over there. It doesn't matter. But anyways, those are some examples of explicit or implicit differentiation.